What happened to the 3D figure who robbed a bank? He was sent to Prism. Get it? Prisms. And today we will be learning more about prisms and cylinders. So first of all, let's take a quick look at your math chart formulas. And we're going to be looking at 3 of them on here. So you could actually, for our notes right now, we're not going to worry about the pyramids. That will come another time. We're going to be looking at volume of a prism or cylinder. We'll look at the lateral and total surface area for prisms and also for cylinders. So now, where do these formulas come from? If you look here, this is a triangular prism, but it works pretty much with any of them. The volume, which you were introduced to, I believe, in 7th or 8th grade, you have the base is this big area on the bottom. So they have the 2 bases colored the same color. And then the lateral areas are the faces, and those are kind of the tan colors right here. Well, these edges give you the height of the prism, and if you could figure out the area of this base times the height, then you would find the volume. So they often call this base here capital B. Don't confuse it with little b. It's capital B. It's kind of annoying because we have little b when we're looking at 2D figures for the base of, say, a trapezoid or a triangle. Now, we take this triangular prism and we unfold it, and you can see that the 3 lateral faces here all make rectangles if it's a right prism. And to find the area, if I put all 3 of them together, I have a long rectangle. The height is still h, and the width here is just the perimeter around the base of the prism, so it's a plus b plus c. So to find this lateral surface area, I just take the perimeter here times the height, and that leads to this formula as S equals P times H. Now, if I want to find the total surface area, I need to add in the 2 bases. So there's a base here and a base there. They're not real specific, so they use the capital B. That way you can deal with either a triangular prism or a hexagonal prism. And now we look at the now we look at the volume. We already talked about that. So let's take a look at a cylinder. The volume for a cylinder works very much the same. You still have a base at the bottom, and there's the height. And if you multiply those 2, you will get the volume of that prism. Now, to get the surface area, it's a little more interesting. If you were to unroll the cylinder, and I can show you how that works, if I cut off the top and cut off the top, imagine a can, and then you sliced it and opened it, this is the shape you would get. And this distance here is the same as the distance around the circle. And that is called the circumference, or 2 pi r. So this is a rectangle with a, excuse my writing, with a length of 2 pi r and a height of h. And so when I multiply those 2 together, that gives me this right here. And then I have to add in 2 bases or 2 circles, and that's just 2 times pi r squared. Now, some important terms. First of all, when you're working on these problems, write down the information. And like I said before, lateral face is any face which is not the base. So we have the bases were colored blue, and they're on top and bottom. They're always parallel. And the lateral faces are the ones that connect the 2 bases. When we ask for the lateral surface area, we just want you to sum all the areas of all the lateral faces. You leave off the bases, so don't include those. If I want total surface area, you take the lateral all around the side, plus the 2 bases. Now, a right prism, and I didn't say prism or cylinder, because this applies to prisms or cylinders. If they are right, then the lateral edges or axis are perpendicular to the bases. If it's an oblique, it's not perpendicular, so it looks like it's slanted over. Now, some of the variables you'll see in the prism formulas, H is height or altitude. B stands for area of the base, not to be confused with the length of the base like on a trapezoid. And P stands for perimeter, the distance around the base. When you're dealing with cylinders, radius is still the same. Radius is the distance from the center of the circle to the edge. H is height or the altitude. And you also actually do have bases when we're dealing with surface area. So, doing the steps, write down the formula for the correct solid from your math chart. Rewrite the formula. Then after you write it out, go ahead and write it out. I want to see them written in your problems. Then I want you to take it and write underneath it. You're going to put in all the numbers you know. So ideally, you've gone and you said H is this, or perimeter is this. Then you, after you've written your formula, you put the numbers in, you substitute. And then you solve the equation you get algebraically for the unknown. Now, when you get to your final answer, make sure your answer includes the correct units. Area is units squared, and volume is units cubed. Area is 2-dimensional, volume is 3-dimensional. So let's take a look at some of the elements of prism, some of the things you'll want to label when you're doing your problems. So first of all, I've got 2 prisms up here. One is a right prism. See how it's vertical and nice 90-degree angles. And the other one's an oblique prism. The components are the bases, which are the 2 colored here, the 2 triangles, and these 2 both have the same bases. They both have lateral edges, which are marked in red here. And then they have the base edges, those are used to determine the perimeter. And then they have the lateral faces, which we'll use for lateral surface area. For elements of a cylinder are pretty much similar. So I have an oblique cylinder, this time on the left, and I have a right cylinder on the right. You can tell because it makes a 90-degree. The height is the same as the edge there. Here, the height would actually drop down something like through there. So it'd be this short distance right here. Here on this prism, you would drop a line straight down, and then this distance would be the height. So the components for cylinders, we also have a lateral surface, and we have an axis, which could be the height if it's the right cylinder. And you have the bases. Now let's go ahead and start by looking at an example. We're looking at sections 10-4 and 10-6. So we're going to be looking at lateral area, total surface area, and volume for quite a few of these problems. The lateral area is the easiest thing to find for prisms because prisms are just made up of little rectangles put together. So the first thing I did is it's the perimeter times the height. Remember, when you unroll the prism, it's just a long rectangle. I figured out the perimeter was 12 because that's the side there, times 6 because there are 6 sides, and that equals 72. So they say take the perimeter, there's my 72, and I put it in, multiply it by the height. So I should have labeled this as the height, and this is the side here. So multiply that by my height, and that gives me the lateral surface area. So the area of these pieces all the way around is 1,080 meters squared. Now I want to find the total surface area. Well, what I'm missing are the 2 bases on top and on bottom. So when I'm going to find an area of a hexagon, if you might remember, the area is 1/2 times the apothem times the perimeter. I've already figured out the perimeter, so I need to find the apothem. For a hexagon, the central angle is going to be 60 degrees. So that tells me this angle here is 30. Now, this reminds me of, for my math chart, the special right triangle, the 1, 2, square root of 3 triangle. So I can set up a proportion and solve for A. Or you might notice that if I wanted to figure out this side, the hypotenuse on my math chart one is always twice as much as this. So I could figure out that's 12. I also noticed that the long leg is square root of 3 times the short leg. So A is square root of 3 times 6, and that gave me the apothem right there. Then I use the formula for a regular polygon. 1/2 the apothem times perimeter. Notice how I did the capital B. That stands for this area of the base. So 1/2, the apothem is 6 square root of 3. See how I brought it down here? Times 72. I probably could have put a little dot there. When I multiply the 1/2 times the 6 times the 72, I get 216 square root of 3, or 374.1 meters squared. Now, to find the total surface area, I have to add the two bases plus the lateral surface area. I could have rewritten out the formula, but since I already figured out the lateral surface area, I knew all I was missing were the two bases. So 2 times 374.1 is 748.2. Use my calculator, add that up, and I have 1828.2 meters squared. Now I'm going to find the volume. Volume actually is quite simple. It's just the area of the base times the height. And you'll end up doing a lot of your volume work when you're doing surface area work. So I recommend that you do area parts of the problem first and then get to the volume. So we already found B. We said it's 374.1. So I'll put it in here, and height is 15. Use the calculator and I get 3,611.5 centimeters cubed.